Okay, so this is the actual coding part of my project. So I said this in the last video, but here's like the data that I used. So it's all on this website. It's called RotoWire. And then it basically just has stats for batters and pitchers from the 2019 season. And then at the bottom, you can export the data to a CSV file. So there's two separate CSV files for batters and pitchers. And then once you do that, it takes them into this document. It's basically the same thing. This Apple program just formatted it into a table, but it's really a CSV file. And then here's my actual program. So this first cell of my program doesn't really do anything when you run it. It basically just takes the data and puts it into two data frames, one for batters, one for pitchers. So first, obviously import the required packages and then use the CSV reader to import the CSV file into a reader format, and then I turn this into a list. And then I got rid of the first. It's actually a list of lists. I got rid of the first element just because it was it was just the headers, like right here. It was just age, games, game start. It was just all that. So I removed that for now. So this just gets a list of data for batters. And then I did the same thing below for pitchers using the pitchers CSV file. And did the same thing deleting the first element of the list of lists. So first I created the batters data frame. So I made a list of all the batter stats that I wanted to create as the column names. And then down here, I took the data and used pandas to put it into a data frame using the list of lists with batter data. And I used the batter stats list as the column names. So then I needed to put the data in the right format, since at this point it was all strings, and some of them I wanted to be strings, like name, position, that sort of thing. But for most of them, they need to be in number format, so I converted most of them to int, and the last four that were decimal numbers I converted to floats. So then I basically did the same thing below with pitchers. I took all the pitcher column headers and then used Panda to put it into a pitcher data frame called pitcher DF. The one above was called batter DF. And then I did the same thing with converting the data type. Most of them were also ints, but there were a few that were floats. About, I think, 1, 2, 3 of them were floats. So this cell doesn't actually do anything to the program, like any visualizations, but it's just necessary to just set up for the other visualizations. So then this is my first visualization. It basically, the user enters a threshold value and it prints all the players above or below that threshold value based on what they pick. So I started off I made this list of pitcher and batter and above and below so I can use it with interact as the two options. I just decided it would be best to declare that at the beginning so I didn't have to add it in the actual interact. And then for the batter options, it's basically the same as the batter options I did above, except it's just the quantitative values, so no name or position or anything, just because I want to have stats that I can compare easily. And then I did the same thing with pitcher options, just the quantitative stats. So then for this first function, it was basically just allowing the user to pick between pitcher and batter, because the statistic choice would change based on which one they picked. So it would either go to pitcher options list or batter options list. So inside this, it calls the interact function. Actually, I'll go to the bottom first. So basically, the last line of the code is actually the only one that runs. It just runs that first function, and the first function calls the rest of the functions. So it's sort of just a bunch of functions that call each other. So this first one either calls the batter interact function or the pitcher interact function based on if the user enters batter or pitcher. So for the first one, batter interact, it calls a different function based on which stat the user enters, because obviously there are some stats, there's only going to be a few of them, like caught stealing. There aren't many that are over like 10, so I didn't want to use the same a slider for caught stealing, and something like at bats, which there are just hundreds of them for most players. So I was having some issues with using the same function for all of them, so I ended up just making different functions based on how large the values were. So basically it just checks what the user enters as the statistic choice, and then calls a function and gives the correct parameters. Some of them I also use the fixed keyword for interact to keep the same value that the user already entered, so they didn't have to enter it again. So it basically just does this for batters, and then it calls the function. All these functions are essentially the same, so I'll just go through one of them. So the first one, if the user enters above, it goes through every value in the data frame, which is basically every player. And if that player at the statistic choice is greater than the threshold that the user entered, it'll print the player and then their team and then how many of the statistic they have. And then if I do below, it basically does the same thing, but for below, it just does less than instead of greater than. So all these functions are basically the same thing, they're just for different stats. And then below, I did the same thing for pitchers based on like their stats. It takes the above, below, and statistic choice from the user, which was called in the first function. And then basically just based on the stat the user enters, it calls a different function, which also does the same thing, except it takes stats from the pitcher data frame instead of the batter data frame. So these all essentially do the same thing. So that's about it for the code for the first visualization. And again, here is just the interact, which is basically the only line of code that isn't in a program, except for initializing some of the arrays or lists. So the next one was a pretty simple program using Plotly Express in my data frames. So same thing as above, just batter and pitcher options. And then it's the same batter options as in the last one and pitcher options. I just decided to declare them again so the user wouldn't have to run the earlier program if they just wanted to run this one. And then this yes or no list is basically just a no yes, and it allows the user to decide whether they want to split up the graph by position using Plotly Express. So first it calls this function. The user either picks if they want to compare batters or pitchers stats. So the first one we'll call the batter graph function, and the second one we'll call the pitcher graph. So if the user doesn't want to graph by position, it'll just make a scatter plot of the two statistics that they enter up here, and it gives the player name when the user hovers over it. And if they do want to graph by position, the facet columns changes to position. So it'll sort the players by position. It'll create separate graphs for each one, like so. And then just prints the graph at the bottom. And then for pitcher, there's obviously only one position for pitcher, so there's no option to split by position, but it basically just does the same thing as the batter graph if you didn't want to graph by position. So basically the user enters if they want to compare batters or pitchers, and then the two statistics they want to see the correlation between, and then for the batter one, if they want to organize it by the position. And then similar to the last one, this is just pretty much the only line of code that actually runs, and then it just calls all the other functions just to interact. So then on to the last one. Same thing, just allowing the user to pick batter or pitcher. So the thing that's different in this one is it's the list of all the teams in baseball. And this program basically allows the user to compare two baseball players. So instead of having the user go through every single player in a list, it's just a lot easier for them to pick what team the player's on first, and then there'll be a much smaller list, down to like maybe 15, 20 people, and it's easy for them to find the player they're looking for. So then this batter options list is also different than the ones above, because this one is actually, I got rid of some of the stats that aren't quantitative, obviously, and I got rid of like the age stat because it's not necessarily something that we need to compare for batters and pitchers. So it's basically just the stats we want to compare to determine who's like a better player. So then I made this list. It's called bad stats. So my program checks if one player's higher than the other in a certain stat, but for pitchers, you don't want to be higher in these stats. So giving up hits is not good. Giving up runs is not good. You don't want any of these stats, so it just takes that into account later. So then here's the main function. So it just creates two blank arrays, and it goes through the teams that the user will enter two teams using a interact. And based on the teams they enter, it'll basically make a list of all the players on that team, and then that'll be used in the later function, which is called batter graph or pitcher graph based on what the user enters. And that'll allow them to pick the actual player that's on the team. So this gets all the batters on the first team into a list and then uses it down here in the interact. And same thing for second team, and same thing for the pitchers down here. So then basically for the actual graphing, these two lines get these two if statements get all the data for the first and second player chosen, and then they're basically in data frame format at this point. So these two list commands actually turn into a list. So then I also deleted the first few elements of each list because there were like non-quantitative stats like position, team, age, things that we didn't want to compare. And then I just created some blank arrays and variables that would be used later for comparisons. So this is essentially the main part of the program. So if P1, it just went through the whole list, and each player had the same stat at the same index in the list, so basically compared each index. And then if the first player had a higher value than the second player, it would go, and these were what I was talking about with the bad stats. So the batters don't want to have more strikeouts or more caught stealing. So if that was the case, then it would add 1 to player 2 and add that stat to their P2 wins list. And otherwise, if it was good to have a higher stat, then it would add a point to player 1. And this does the same thing as above, except it was if P2 is better than P1. And then this basically at the end, after it's done going through the for loop, it just creates a list with 2 entries with each player's count of their like winning statistics, like how many they have the advantage in. And this essentially creates the bar graph using matplotlib. So I used plt.bar, and then I changed the x values to the actual player names and then just the labels and titles. And then below that, I printed out the actual stats that each player had the advantage in, just to show the user exactly which stats each player is better in. And then this is the function for the 2 pitchers, basically the same thing. Takes the data, puts it into 2 lists, and then created the blank arrays. And here's where I use the bad stats thing. So if pitchers have a bad stat, like more runs or more earned runs, or more hits allowed, or more home runs allowed, then it would not take that into account as a good thing for player 1. So it would actually give the point to player 2. So basically it does the same thing, just creates a bar graph and then prints the player 1 and player 2, which stats they're better in. And yeah, that's about it. It just calls the interact function at the end, same as the last 2 programs. It's basically just, that's the only line that runs. It calls the first function, and then that function calls the rest of them. So that's about it for the coding part of my program.